Okay, next we're going to look at review, Unit 3 review problem, exercise 16. According to Reader's Digest, June 2004, the mean amount spent on a high school prom is $638 with a standard deviation of $175. Random samples of 36 prom goers are sampled, and the mean amount spent on the prom of each sample is recorded. Describe the distribution of sample means, being sure to describe its shape, center, and variability. What is the probability that one of these sample means is between $600 and $700? In other words, if you take one of the sample means, what's the probability that it is between there? And 90% of all these sample means will be above what amount? See if you can work this out now. Press pause. Well, this is what we call a sampling distribution. Since the sample size is 36 is above our sort of magic number 30, the central limit theorem tells us that the distribution of sample means is approximately normal regardless of the shape of the distribution of individual values. I did not have to tell you anything about the shape, and I didn't tell you anything about what the distribution of individual values look like. The mean of this sampling distribution is the same as the mean of individuals, so it's $638. The standard deviation of sample means, also known as the standard error of the mean, is the standard deviation of the individuals divided by the, that should say square root of the sample size. So what I do here a lot of times is I'll just take the mean, 638, store it as m, the standard deviation. I want to take the 175 and divide it by the square root of the sample size, so it's 175 divided by the square root of 36. Store that as my s. So I don't have to type all those digits in again. So that's the standard deviation of the sample means, the standard deviation of the x bars, also known as the standard error of the mean. So that's about 29.17. So about $29.17 is about the standard deviation we'd expect on the means. Now, what's the probability that a particular sample mean will be between $600 and $700? Percent sign missing there. All right, well, that's just a normal CDF between 600 and 700 with that M and that S, being sure that that S is this standard deviation of the sample means, not of the individuals. That's an easy place to make a mistake on this problem. And so that turns out to be about 88.69%. 90% of the sample means will be above what amount? Well, 90% is above will be that's 90% to the right. So this is going to be an inverse normal problem. So you're going to have to give it the probability to the left. 1 minus 90% is 0.1, which is to the left. So it's inverse norm of 0.1 with our mean and standard deviation that we're dealing with, which is about $600.62. So 90% of the people will spend over $600.62 on the prom according to this information if it were correct. So this is an example of what we call a sampling distribution or sampling distribution of the mean problem. Notice that we didn't have to have the data be normal because our individuals didn't have to have a normal distribution because the sample size was pretty large, and that's making use of the central limit theorem.